Thanks very much, Simon. Let me just share my screen and move to the presentation. So thanks for being with us today. We've got a lot to get through, and we're going to go through it at quite a clip. So please, if you've got any questions, just put them in the chat box, and we'll deal with them at the end. So as Simon just mentioned, the global. Okay, so there we go. So this year, the hottest on record, there's multiple different ways of measuring it. They're all showing exactly the same trends. I won't dwell on that because it's kind of, it's kind of self-obvious. We've just experienced our warmest spring on record with the fires and the floods and the storms and the, football-sized hailstones. All of the kind of worst-case predictions are coming true. And the reality is that the construction sector is one of the major generators of carbon emissions one way or the other. So as a result of that, there's a number of sustainability megatrends that have been identified at a World Green Building Council level, one of which is climate action, the other being resource efficiency, which actually, when you consider that energy is also about resources, then the two of those really work together. So ultimately, when we talk and we look at the World Green Building Council's priority for what they call advancing net zero, so net zero carbon, there is a twofold front. There's the embodied carbon front, and there's the operational carbon front. And the embodied carbon front, it actually occurs at all of the, throughout the whole life cycle of a building, and it's embedded in the products and actually sometimes in the services, but the services aspect tends to come into the operational side of things, unless it's about procurement, in which case it's about how you buy products still. So ultimately, the vision that is being advanced by all green building councils, including Australia, is a 40% lowered embodied carbon profile for all new buildings by 2030, and by 2050 net zero embodied carbon for all new buildings, with all existing buildings being operationally net zero. So this is these are really tall orders, and the problem is we've known about this since the early 70s, and we've basically done nothing about it for 50 years. So all of a sudden it's on us in a big way. Fortunately, even though we've had a extremely intransigent federal government over a number of years, we have got action by state governments, to the point that with Northern Territory coming on board very recently, only as recently as July, every state and territory in the country has made net zero by 2050 commitments. So even without the federal government, the whole nation is committed but that doesn't mean to say we don't need still federal commitments to lock in at the same level, because there's a lot of spend that the federal government directs, which is important to direct in the correct way. We even have one state that is claiming to be a world leader. Tasmania now confirms it is actually already hit their net zero emissions target, not just by 2050, but by now, and in fact for the last 4 years. And they are also in the process of expanding that by generating and putting out a commitment to be 200% carbon positive by installing new renewable generation, which it then intends to export to the rest of the country. We have policy standards, the national carbon offset standards, being launched by the federal government in accordance or in alliance with the Green Building Council of Australia, something at least that they've done. And most importantly, we have the whole investment sector, the people who drive the money in the building construction industries, saying that really this is the way that buildings have to go, because if we don't deal with this properly, then they're going to be looking at a devaluation of real estate values of at least 30% in coming years. So they're keen to do that. Now, obviously, the industry at large has taken action, and the various declares, whether it's architects, obviously builders declare. Thank you, Simon, and the rest of the team. And engineers declare. There's literally hundreds and hundreds of organizations that have made those commitments. And the reason they're doing that is really because construction and operations account for 36% globally of final energy use, with 28% of CO2 emissions worldwide. And when we look at the different kinds of buildings, so blue is operational energy, pink is embodied energy, and we have three scenarios: existing world building standards, improved world building standards, and advanced new building standards. And you can see that very quickly the operational energies drop, and we don't get much improvement on the operational energies. But look at what's happening with the embodied energy. As we go to the new and advanced operational energies, embodied energy is climbing. So we really, really need to be careful about this, because so the studies that are looking at this in detail are showing that by 2050, almost half of the emissions in new construction are going to be in the material. So the embodied carbon is half of all construction emissions by 2050. And the thing is that we actually have a unique, once in a lifetime, in fact, once in the history of the world, opportunity, where the growth of wealth, which is the blue curve G&I, is decoupled from the growth in greenhouse emissions. The more renewable energies that we can build into the system, and the closer that the operational grids get to carbon zero emissions, the more disconnected wealth generation and the economy will be from global emissions of carbon. Now, so then the question is, well, how do we get there? If we decouple it and we have committed to not generating nearly half the emissions in embodied, how do we achieve the reduction in emissions? What have we got to do to get there? So we've got a whole lot of things that studies that have been done. So the Cooperative Research Centre for Low Carbon Living has put out a whole lot of design guides, targeted at specific sectors, and one for each sector, even for households themselves, particularly residential new builds, commercial buildings new, commercial buildings retrofit, social housing, and so on, even precincts. And all of the different rating tools that are in use in Australia. And some of you might not think that LEED is used in Australia, but it actually is. Somewhere around 7 to 9% of Green Star projects are also LEED certified, because they're typically for American corporations, and they do both. All of these tools are focusing on embodied carbon, even now in their current iterations, and are moving towards ratcheting up the bar as we move through. The one that isn't often used, in fact, I haven't found a recorded use of it in Australia, but it is still a global tool which focuses on carbon, is BREEAM. Now, if we look at the current Green Star design and as-built, which is the basically the base building tool, it currently has a life cycle impact credit, which is worth up to 7 points, where it's a comparative saving, and you get points where the project makes savings against reference a set of reference specifications. And then in the interiors tool, it's up to 18 points with a variety of different options to achieve those points, and up to 7 additional points where the life cycle analysis is used to inform the building design process. So we have a huge emphasis now on reducing the overall by 25 to 30%, and that's as it stands today. But as has been recently launched, Green Star Future Focus is coming into play from next year, running in parallel with the existing design and as-built tool, and it's taking a slightly different approach. The product relevant sections are called responsible and positive, and we have responsible procurement, structure, envelope, systems, and finishes. And then we also have upfront carbon emissions and impacts from resources. And together, they're worth more than 20% of all of the available points. So the emphasis on products is being really strengthened. The new tool is called Green Star Buildings, and it has a whole new structure. Again, the two sections that we're mostly interested in at a product level are responsible and positive, although resilient also has a very substantive impact too in terms of the specification in relation to the resilience of products or the resilience of buildings. This new Green Star has stated intentions to deliver a new definition of sustainable building, to meet the Paris Agreement, to respond to the sustainability megatrends I've just mentioned, and to create clear expectations for new buildings. So there are 10 minimum expectations that include energy efficiency, water efficiency, healthy spaces, and building responsibly, and on sites that aren't critical natural areas. But in addition to that, 6-star buildings have to be designed to be fossil fuel free, highly energy efficient, powered by renewables, built with low carbon materials, along with a net zero carbon operations path. So they're also going to extend that definition to other star ratings over time. So we're seeing a really significant ramp up at a building level here, but we're also now driving opportunities for supply chain transformation. So introducing a new framework for assessing products and materials that's a scorecard based. So they're looking at products, what aspects of products need to be brought into the public domain, and then scoring each of those on a scale and giving each rating system a score, and then to work in a particular sector, like in the responsible structure, you have to use to gain a minimum of 10 points to be able to have a building assessed, a product assessed in that category. And then 7 points for things like services and 6 points for finishes, that sort of thing. So each element of a building will require certain levels of scores to be achieved, and the rating tools, or the certification bodies that are certifying the products, will be putting forward certification services that will generate those points, different points for different services. Like, for instance, there might be extra points for enhanced transparency, whereas an eco label might just be a pass or fail. If there's a transparency report for things like ingredient toxicity hazards, that might get another 2 points, sort of thing. The other thing is it's going to be creating a driver for low carbon products and driving the need to generate metrics, real embodied carbon figures for products. Now, you may not have heard of EarthCheck, but EarthCheck is a Brisbane-based scheme that operates around the world. It's in over 70 different countries. It typically is in the tourism and exhibition and conference and transport field. So, airports and the state conference and exhibition centers and so on. And it actually provides one credit point up to 3 for every 25% reduction in cumulative impact using full-blown life cycle analysis and environmental product declarations. So likewise, the infrastructure sustainability rating tool has material life cycle impact measurement and management credit, which is an essential part of managing the overall impacts of an infrastructure project. So pretty much every rating tool that operates in the Australian sector, with the exception of WELL, which is just focused on health, is requiring an analysis and a driving down towards zero by 2050 of embodied energy as well as operational energy in buildings. Now, the only way that you achieve meaningful carbon metrics is to use life cycle analysis. And a life cycle analysis looks at all of the global impacts, not just carbon, everything, from raw materials through manufacturing, including transport, packaging, waste, recycling, how the product gets used, cleaning, maintenance, the length of its life cycle, what happens to it at the end of its life. Does it go to landfill or can it be recycled? And basically quantifies all of this for every ingredient and every component in a product, and then quantifies it and puts it all together in accordance with an international framework, which looks like this. So the overall framework is ISO 15392, and then there's a variety of sustainability indicators in the next standard. And for buildings, the key overarching standard is ISO 21931-1. So it's the framework for assessment of environmental performance of construction works, Part 1 buildings. Now, that's at the building level, and at the product level, we get down into a thing called an environmental product declaration, or an EPD. EPDs come in a variety or are able to be declared under a number of different standards. At the very sort of overarching level, you've got ISO 14025, which is for all products. And then we have two other standards, EN 15804, which is a European norm, and ISO 21930, which is the international standard, which are both about environmental declaration of building products. In Australia, it's EN 15804 that, particularly from next year on and into 2022, Green Star and all the other rating tools are focusing on requiring. At the moment, Green Star recognizes ISO 1425 EPDs as well, and will continue to do so through to the end of next year until the current Green Star design and as built is phased out in 2022, as I understand it. Now, when we look at life cycle analysis, there are different stages in the life cycle, and we're typically used to hearing of a cradle to end of life type extent of life cycle stages. But there's a new section been added called Module D, which is effectively beyond the normal life cycle, and it looks at the benefits beyond most system boundaries into reuse and recovering and recycling potential. So ultimately, when if we've seen an EPD in the past, most manufacturers, particularly multinational manufacturers, will work just in these first A1 to A3 stages, and this is called a cradle to gate EPD. It's raw materials, transport, and manufacturing to the point where the product is being delivered from the factory, including packaging. Now, this sort of avoids having to look at what happens to the product once it gets into the building. It avoids the transport being factored into when the product is delivered to different countries. It's convenient for the manufacturers, but not very convenient to use for a life cycle analysis consultant, because basically they have to add everything else on top and do their own calculations. So it means that everybody's using a different set of data to get to the same impact of that same product in a different building. So ideally, you would be looking for the environmental product declarations. And just to be clear, an environmental product declaration is essentially a summarized life cycle assessment report. So a normal life cycle assessment report can be 100 to 200 pages. No one wants that. So the standards I was talking about have standardized the way they should be summarized. And I'll show you an example of one in a moment. But the more useful EPDs are those that provide cradle to grave or cradle to end of life fate stages. And now there's the inclusion of a cradle to grave plus, where there's a module D included in the data. We also need to look at what the scope and boundaries of the study of an EPD are. And again, to some extent, these are included in the standards, but it's important to make sure that, particularly if you're using EPDs to compare products, that you are aware and make sure that the scope and the boundaries are the same in the studies. So ultimately, we have what's called scope 1 and 2, which is the section that's inside the dotted line, which really is all of the aspects that are under the control of a manufacturer. We then have scope 3, which are the things like the embodied impacts of the trucks and the rail and the roads and the buildings in which they're built, and the primary extraction of resources for energy, all of those sorts of things that are outside the control of the manufacturer up front, and then also those that are outside the control of the manufacturer after the end of life. So most EPDs are only scope 1 and 2. And once we get into cradle to gate plus EPDs, then they are looking effectively at a study of the end of life scope 3 issues. The subjects that we're looking at typically boil down into the topics that are in green, yellow, and orange. So global warming, mineral and fossil use, which is called abiotic resource depletion, land transformation, water depletion, eutrophication, which is the adding of things like fertilizers to water, acidification of the air, ecotoxicity in water, photochemical smog, ozone depletion, and human toxicity. There's a few other issues that are sort of looking at being added, but at this point they're not added. And they sort of boil down into endpoint sort of the damage categories, where we've got climate change, resource depletion, ecological quality, and human health. Now, here's a list of materials with kilograms of CO2 per kilogram of product data involved. And you can see that at the very top of the list, you've got aluminium being the highest of the list, and then you get sort of closer down the bottom and you can see, well, gee, cement and concrete, they're really small numbers. Oh, they must be fine. What you've got to be careful of when you see numbers like this and try and use them is the different mass of the materials. Because once we start looking at mass, the way we calculate embodied energy is to look at that carbon factor, multiply it by the material quantity in mass, and then basically integrate that with the building model. So when you do that, things flip around really quickly, because obviously there's a lot more mass in concrete and there's a lot more of it in a building than there is aluminium or the ilk. So here's a fragmentation diagram, a couple of pie charts of the embodied breakdown of materials of a student accommodation project called Spring Mews in the UK. what you see here is a breakup, and there's no real kind of concrete, but looking at the drawings that I was looking at, basically with the exception of the frame, or about 50% of this project is actually about concrete, whether it's foundations or ground floor or upper floors and structure. Basically, the building's nearly 50, building embodied carbon emissions are nearly 50% generated by the concrete. And then if we look at a steel framed multi-story skyscraper, we've got 23% of those emissions coming out of, it says here cement, but that's really about the concrete in the building. And you can imagine that if this was a concrete frame building, that the 37% that was in the steel structure would be also bulking up towards 50% due to the concrete. But either or, 50% of this, even this structure is of this building is due to the structure. So a little bit closer to home now, I'd like to introduce you to this building, which is Josh's house. You may recognize it from the ABC show of the same name. Josh is a presenter on the ABC, he's also a building designer, and he did this project, and they used a tool called the E-Tool to do an embodied energy analysis of it, which I'll talk to. Well, it's very pleasant building, very contemporary. That's a more recent shot of it, showing the landscaping a little bit better established. Very pleasant, open planned interiors. It's a nice house, very nice house. Now, let's just have a look at how the comparisons work out here. Now you can see up the very front that the services, where have I got a pointer? Yeah, here we go. So the yellow is the business as usual brick veneer Perth home. Services are a small part of the componentry. The mid color green is what got built, and the dark color green is the E-Tool recommendations that actually were not adopted. So as you go to, as you can see, obviously the dark green is the lowest impact all the way along. And to do that, you've got to increase the embodied impact of the services. Most of these is probably going to be solar hot water systems and PVs and extra fans and those sorts of things. So we increase the energy here, but dramatically increase the energy in the walls, in the roof, in the interior finishes, in the floors, and pretty much everywhere else. Now let's just look at it in terms of the global warming profile. So the embodied impacts don't vary dramatically over the three different options. Obviously, the two preferred options are better than the base level building. Obviously, look at the operational impacts, or huge different in the operational impacts, where both of the preferred designs are actually generating excess energy, whereas the business as usual one is consuming energy, or emitting carbon and saving carbon. And so you might be inclined to think, well, that's really interesting, but why do we put all this effort into this bit here? Until you look at this pie chart, because this building is net zero carbon operationally. So the operational impacts overall in terms of carbon emissions of the actual building outcome is 0%. There is no carbon emitted. The embodied impacts are 100% of the impact. So do you understand that? The carbon emissions of operational is 0. The embodied impact is 100%. And this is why 50% of all emissions into the future till 2050 are due to embodied impacts. Now, this is an interesting analysis because this is the net payback. This is actually showing that the crossover in payback on actual dollars based on today's energy prices are in the 5.5 to 7 year zone. So basically, even on today's electricity prices, you're getting a 5 to 7 year payback. And as electricity prices increase into the future, which inevitably they do, that payback rate will come down. Now we're seeing this at a commercial building level. We're seeing net zero operational buildings in commercial sectors in places like Germany, where they're using high levels of energy efficiency and photovoltaics and ground source heat pumps for the space heating. And they're approaching net zero in embodied energy by basically building with timber. Now, this is a very dramatic view of the Lend-Lease building at 25 King Street, Brisbane, which I've been to a number of seminars in now. It's a very, very pleasant building. It really feels different, but it's basically a completely timber building with a couple of minor exceptions. This is the kind of the face of building to come, because this is really the only way we build buildings that can mitigate their impacts until they figure out how to build zero carbon steel and zero carbon concrete, which they're definitely working on. And we're seeing a lot of work in that space at the moment. But at this point in time, essentially the cross-laminated timber is the leading way to get there. So then this raises the question of, well, where do I find out about all of this information? Like, what are the best places to go to? Where do I get access to finding out what materials have what kind of embodied impacts? And this is where, I'd like to put on the table the work that Greentag does, because ultimately we do deep scientific dive into products, and then we make public the results via a series of rating systems for certification tags, various transparency reports like environmental product declarations and product health declarations. But we also do product rating schemes that are based on life cycle analysis that compare the product under question to a base product in the market that performs the same function. So on the homepage of our website, you will find a product finder that enables you, with the push of one or two buttons, to find products with carbon information. And you can do that by looking for products that are certified with our certification called LCBA, or you can look for a product with EPDs. There are slightly more products with EPDs than LCBA because we have some clients that just do the EPDs and don't do LCBA, but there's not many. So you can pretty much use the two interchangeably, and the results that you will get look like this. You can see a published EPD, and you can see that on each one there's an Adobe Acrobat symbol. If you click on that Adobe Acrobat symbol, it will download the EPD for you. It tells you under which standard it's been certified and its currency date. Likewise with the LCBA result, when you push the LCBA button, it tells you what the product name is and what the result is, and you can then click through from the name of the product through to the product report page, and I'll show you what that looks like in a minute. But first I want to actually tell you or show you what LCBA is. As I said, it's a life cycle analysis based rating tool. It's effectively a type 1 third-party certification system, but it's not just a pass-fail label. It's not a label that you get or you don't get, and you really just have a rough idea about what products are preferred compared to the products that aren't certified. In this instance, we go beyond life cycle analysis and fill in the gaps where LCA doesn't really tread or doesn't do as well as it could. things like in building synergy, that is how the product improves the performance of the building once it's installed. Health and ecotoxicity in a very detailed ingredient by ingredient analysis fashion. Biodiversity, that's the physical biodiversity of resource extraction, not the chemical one, because LCA does a reasonable job of that. Then we have the life cycle analysis score, the greenhouse gas score with actual metrics, and corporate social responsibility. Now, you'll see there that it says the score range is -1 to +1. +1 is normalized to the business as usual worst case performance of a product that performs the same function. And the score that you can see there is normalized towards 0, where 0 is a net zero impact, and minus scores are better because they're where the product is taking existing impacts away from the environment. That is, they are net positive products. So the scoring system is calibrated so that the lower the score, the better. And the way you read it is a product that has an LCA score of 0.1, as this tag is showing, means that it's 90% better across the whole of its life cycle score than the business as usual product. From a greenhouse gas point of view, at 2.45 kilograms of CO2 per square meter, this product is 75% better than the business as usual category product. So 0.25 is its score. That means it's 75% better than the business as usual. Hopefully that's clear. The system is based on full-blown life cycle analysis, which is ISO 14040 and 44 compliant, and it boils up by the weighting of the scores that we were just talking about into an eco point, and the eco point score is then used to generate a bronze, silver, gold, or platinum rating outcome. Each tag or each scorecard that you see for a product actually gives you a greenhouse gas emission metric. And don't forget that you can use any one of these scores to assess how much better than a typical business as usual product that's commonly available in the market is. And then we use a weighted average to get to this Greentag eco point. So you have 3 ways of comparing any product that's in the market that is LCA, also LCA rate certified, that performs the same function. So whether that's a wall board, a paint, a ceiling, a non-ceramic tile floor, a ceramic tile floor, each of those has a business as usual product, and anything that's certified in that category, you can compare the product and product scores directly. And of course, you can also compare the greenhouse gas score. Now, the thing about LCA rate is it gives us the information to be able to generate something that we call carbon rate, and I'll show you what that looks like later. In the meanwhile, let's have a look at how this information is available to you online. So when you click on one of the product names in the product finder, or you search for a product via one of the other 4 search functions, you get to a product assessment report page that looks like this. You'll notice that there's 2 tabs. There's an About tab and a Professional tab. Now, on the page as it stands, you have the LCA rate or green rate result. I won't go into what green rate means. It's designed specifically for Green Star. It shows you the range of certification options, the level at which it performs, and you can download the product certificate just from the home page or the product assessment report page. When you open up the Professional tab, it actually allows you to access a new level of product, a new level of information. But you can also click on the scorecard here to get a much larger version of the scorecard. And you can also click on the learn more about the scorecard section just there to get a full explanation of what this all means if you need a reminder in the future. Obviously, there's a whole lot of other information there that I won't go into because we're just focused on carbon in this presentation. But what the professional tab allows you to do is to click through to find the product EPDs or product health declaration. So anything other than just the general certificate, you will actually find on the professionals tab.
David, just to clarify with the green tag, the rating. So got a question here. So is one rating, is that standard, and -1, sorry, 0 is standard, 1 is excellent, is it? And -1 is terrible, is that?
No, it goes the other way.
The other way around. Yep.
One is the worst case business usual. So
Yep.
it's the worst case product that's commonly in use in the marketplace. 0 is impact neutral. So it's basically a carbon 0 or biodiversity 0 or health 0 performance. So it's a benign result. That means that the product has no impacts. If a product was able to get a 0 impact in all categories, which at this point is almost incomprehensible. I don't think any product has achieved that, but certainly you can achieve it in some categories like health, like carbon. And like corporate social responsibility, those sorts of things. -1 is the best because -1 is where it's taking impacts that already exist out there in the environment and negating them. So it's actually having a net positive impact in the environment.
Yeah, got you. So -1 is the
-1 is -1 or better.
As good as you can get.
Yeah, we've actually, in some instances in the cyclic economy, we've realized that there's possibilities where we might get to -2 or -3 or -4. Who knows? It's really just about how good we can get with the cyclic economy.
Great. Cheers.
So one of the things that can be done is if you're wanting to research, for instance, flooring, you can look at all of the results of the different products that we certify that all have LCA rate or EPDs and generate comparative graphs. So here's one that looks at the toxicity of all these different flooring products. Here's the eco point score, and here's the greenhouse score. I mean, look at this one. I mean, if you were looking for an underlay, there's a recycled polyurethane underlay here, which is sort of way lower impact than the other top floors. So there's lots of information that sits in the back of that Greentag website. At the moment, it's buried in the actual documents, but we're working on a project that we hope to deliver this year where all of the data that's in all of the certificates and in all of the EPDs and all of the product health declarations will be digitally available to search and be digitally available to other websites as well. And I'll talk to you about what that might look like a little bit later. So the data for a lot of products is already there. You can actually, particularly in the interior sector, you can do a really broad scale search of embodied carbon impacts of interiors products specifically. Now, let's have a dive in more detail at EPDs. We've already talked about the different standards under which they come in. They are relevant to the rating scheme and legislative requirements in the EU, and they're not recognized but compliant with the different rating tools like Green Star and LEED and BREEAM International. But importantly, the carbon metrics that we generate in these EPDs is compliant to the ISO 14067 carbon for quantification of products, which is a separate standard again. So here's what an EPD looks like. The front page is typically a little bit of information about products, some photographs about the company. There's a table of contents. There's a signature page. that gives you the declared unit and the functional unit, which are important things because you're looking at the amount of the impacts of tile per square meter cradle to gate. But the functional unit is actually for flooring 20-year use cradle to fate. So that has an impact when you start looking at the information further into the document. So the functional unit is the one that the reporting in the EPD is done in. It shows you what's in the product, where it comes from, how it's been extracted. It looks at the packaging types. It looks at the whole of life performance in terms of toxicity and effluent and waste. And then we come to the results. So importantly, you're looking at the mass of the product. You've got to keep a careful look on that to make sure you're comparing like for like if you're trying to use EPDs to compare products. It's a tricky thing. You need to be very careful in doing that. But and this is really, this next table is table 8, life cycle impact potential results. This is what the EPD is all about. Those 3, 4, 5, 6, 7, 8 different indicators, or actually 7 different indicators, are the numbers that an LCA consultant plugs into their life cycle models, and that's really what it's about. The rest of it is just supporting information. You've got supply chain charts, all the different processes, and you've got the boundary and life stages and modules that are included, and you've got things like, you know, data source quality and uncertainty assessments, which nobody really needs to understand. But what LCA rate and EPDs together allow us to do is to generate this very simple outcome called CarbonRATE, which again is a brand that can be on a product, and one of them is a carbon reduction. So in this instance, it's a 70% reduction. You can see that the circle is only at 70%, and the actual figure of CO2e per square meter of product is 8.7 kilograms. Then and that 70% comparison is again compared back to the business as usual worst case product. Now with carbon zero, it's just against the product itself, which means that there are no carbon emissions. They've either used renewable energy in the factory or they've bought carbon offsets to effectively create a product that has no net carbon emissions attached to the product as it arrives on the building site. Well, actually, sorry, as it leaves the factory typically, because really so actually that's, so let me clarify that. So if a product's made outside Australia, CarbonRATE allows for the product to be landed and stored in Australia. So it actually does include the transport of bringing it from the factory. But if the factory is in Australia, it's basically to the factory gate because it doesn't allow for travel within Australia. And then the carbon credit is where you basically, the product is a carbon sink. Typically, it's going to be a bio-based product, whether it's a bamboo or reeds or sort of a timber product. It's going to have carbon stored in the mass of the product and is basically going to be providing what we're calling a carbon credit because we felt that actually carbon positive can confuse some people. There's no confusion that this product is 190% of the carbon that it takes. So it's neutralized it at 100%, then it's basically absorbing an extra 90% into a credit context. I hope that's clear. But basically, you can tell from either of these three logos, not only whether it's, or to what extent it's an improved product, but also the actual kilograms of CO2, where, you know, in this instance of the 90% carbon credit, it's a minus 1,000 kilograms of CO2 attached to 1 unit of that product. Now, there's a whole, carbon metrics are being used to design new products. Now, here's an example of one where BVN, or Blyvoll and Neal as it used to be, and UTS have collaborated to work up a full-scale prototype of a 3D printed ductwork system that sits under the floor, distributed under a floor, and they've done it with recycled PET that results with an overall saving of 75% of the embodied carbon. Now, it increases air quality, and for the entire project of a 30,000 square meter net lettable area office building, you'd be reducing the overall impact of the building by 3 to 4% or 750,000 kilograms of CO2. But because it also reduces floor-to-floor heights, it also provides additional embodied energy savings through the reduction of building heights and potential elimination of ceiling grids, that sort of thing. Likewise, there's a product called a Geopolymer cement where it uses pozzolanic materials to replace conventional Portland cement, and the Queensland University's Global Change Institute, as well as Wagner's own Wellcamp Airfield airstrip, is made out of it. And the Global Change Institute building reduced their concrete emissions by 75%, or in fact 11% overall, or 11 million kilograms of CO2. So there are pathways to positive. The thing is that if you just focus on carbon, it's possible to make decisions that reduce carbon but increase other impacts. And we often see this with recycled materials. Don't think for a minute that just because a product is recycled that it has lower embodied carbon, because it really depends on what the product is, how distributed it's been before it's been recollected, what transport is involved in bringing it back to a central point, what energy is involved in cleaning and shredding and turning it back into a usable material. Often recycled materials, while they are better from a resource point of view, can come back with higher carbon outputs than the original materials. So to do that, to make sure that we're capturing all of the unintended consequences, but also all the benefits, because there might be other benefits to a product other than carbon. By doing things in a certain way, it might help clean up the air. Now, traditional life cycle analysis is called life cycle impact analysis. It measures impacts. They are typically negative occurrences on the environment or on health. There is no set of metrics across the world that enable life cycle benefits to be captured until we, together with our EVA Institute partners, developed a set of life cycle benefit metrics that enables the benefits of the cyclic economy and regenerative products to be properly assessed, properly measured, and to be put side by side with the impacts, so that you can make a judgment on whether the impact changes are warranted by the benefits appropriately offsetting them. So there's a whole range of different metrics, and the ones that we're particularly interested in, in terms of this presentation, is the embodied carbon, or the supply of a carbon sink potential. I'm not going to get into this. This is what the technical detail of it looks like, but we're going to flick straight past that and look at what it looks like in real life, because here is a variety of products that are on the market now where the EPDs are already on the website. These happen to both be Laminex products. One's a redback high pressure laminate, and the other is particle board floor, where, as you can see, the greenhouse gas emissions are minus 25.9 kilograms of CO2 for the particle board treated floor. The eco indicator here is minus 0.59. So that's nearly 160% better than, sorry, 160% better than the business as usual alternative. Showing you what these actually look like when we get through into the business end of the EPD. This is the table 8 again. You can see the performance in the life cycle impact results. You have negative impacts only being shown there. Typical life cycle analysis will not show you even a negative carbon figure unless the brief has been specifically asked for it. Like we've seen forest product inventories without carbon benefits attached, only negatives. We've had to say, where are the embodied impact benefits? Where is the carbon sink potential of your wood supply in any of this? Why aren't you measuring the benefits? And they go, oh, okay, yeah, good point. Let's do that. So ultimately, when you look at the EPDs for these products, you've got a series of benefits here: climate security, water security, soil carbon security, forest security, soil health, biodiversity, so on. And then you've got a whole series of numbers with positive benefit outcomes. You can actually, I won't go into detail because we're running short of time, but ultimately we've got those negative impact products also for things like Weathertex, their unprimed flat sheets. They come also with a minus 0.15 eco indicator and a minus 4.72 kilograms of CO2. So you can see that there's a range of products out there that have these benefits. There are other ways of getting this information. There's a tool called EC3, which is a free tool. It's US based, but it is expanding into Australia at the moment. There are 6 EPDs uploaded to it from Australia, as you can see by the sort of mid blue there. It has a variety of different products and product sectors already embedded in it. It's not comprehensive by any means, but you can do really cool things with it, like show carbon heat maps, and you can do carbon flows from different raw materials into the different elements. So some really cool stuff you can do in that. And the other good thing about it is it's a BIM-based tool. You can actually drop your BIM straight into it, and I won't say, seamlessly, because typically BIM isn't seamless, but you can drop BIM elements into it and achieve outcomes, as you can with other carbon tools attached to some things like Revit and so on. There's also this subscription service that you call the Green Book that has data on materials and complex assemblies. And there are data hub where these EPDs are available for a broader range of products from a broader range of sources. Origin.build is one of them. We are one of the services inherent in Origin.build. Again, that's free for users to use. There's also the transparency catalog, which is basically free downloads of EPDs across a range of countries. Both Transparency Catalog and Origin are predominantly US based, but Origin actually is also Asia Pacific focused as well. So we're a little bit over time. Apologies for that. There was a lot to get through, but happy now to take the screen off share and to answer any questions.
Thank you, David. Plenty of information you covered there. I was taking notes like mad. Hard to keep up.
There's a lot of content.
Yeah, for sure. So green tag, obviously, it's a big job. Is it? It's obviously a big job to certify as you do. Yeah, is it a compulsory certification? I don't think any.
No, it's not compulsory.
It's voluntary.
It's voluntary, and basically, if people want to get more of this information, they need to be talking to their suppliers, because manufacturers will often say to me, why do we need to do this? We never get asked for it. And yet the designers are always saying, why don't more manufacturers do it? Well, the only way the manufacturers do it is if you ask them to.
Yeah.
And the way they effectively do it is particularly when projects say to them, you will not get purchased unless we can have an EPD, or unless we can have your green rate or your LCA rate certificate or your product health declaration. And that's when they go to us, that's when they say to us, help, how quickly can we do this? Otherwise, they will just push it down the road until it's going to cost them business.
Yep. Fair enough. So do Greentag also do businesses or just products?
No, just products.
Just products. Yep, good. One question.
Sorry, one qualification there. We're just starting to do modern slavery declarations. And part of the analysis for that, well, actually, part of the analysis of everything we do actually does look at the company, because we have to look at policies and criteria and worker health and worker safety and employment conditions and that sort of thing as part of the corporate social responsibility piece. But we don't pull that out and explicitly talk about it, except in the modern slavery declaration risk analysis process that is responding to the new Australian and other countries' legislation in that space.
Okay. A question here from Jeremy: with regards to timber products having negative carbon scores, doesn't carbon come out of the product at end of life, and how's it accounted for?
Yeah, so this is a really interesting piece of, it's a really interesting calculation, because when we talk about building life, we talk about a building life of 60 years. And so if we're going to use a big chunk of timber and it goes into a building, in 60 years, it comes out as a big chunk of timber and is likely going to be able to be reused. To answer that question, Greentag is completely free to air for everybody. There are no costs involved. It's just globalgreentag.com. Away you go. It's all there, just sitting there for you. So ultimately, the process is completely transparent. Yep.
Okay. Fascinating. Yep. Do you have any idea how much carbon is embodied in the average Aussie home?
There have been studies on that. In fact, there's a study, I believe, in the Australian government's Your Home publication that looks at the Englobo impacts of a single 3-bedroom home. It was done a few years ago, but nonetheless, it's still current because physics doesn't change. What does change a little bit is the intensity of the grid. Interestingly, our Australian grid is getting actually dirtier, not cleaner, because of the fugitive emissions being emitted by fracked gas. Even with all the renewables we're putting in, the actual supply chain is getting dirtier because of fracked gas, because of fracking. Same as the US. China's getting cleaner, we're getting dirtier.
Okay. No good. We'll just go through a couple more questions. One I had was, obviously Greentag goes really deep and it goes beyond the climate impacts. And what would you say is the second biggest, I suppose, the impact of construction practices excluding the climate?
That's a good question.
Might have stumped you.
Yeah, I mean, look, it's probably resource use, abiotic resource depletion, basically the non-renewable depletion of non-renewable resources.
So biodiversity degradation.
Well, yeah. So biodiversity is part of that in one sense. The biggest impact, planetarily, is going to be the impact on ecosystems, no question. Yep. So
which is all interlinked, of course.
Yeah, of course, it's all interlinked, exactly. But we have things that appear on the horizon from time to time. We talk about greenhouse emissions, but then we get to resource restrictions, and we have things like peak metals, where we've got known resources of specific metals, and we're using a lot of them, and we're using it very fast. So that life cycle analysis brings that awareness to the top. And then, so people go, oh, we've got to, develop new technology to move away from this. So, at one point, there was an element in being used in LEDs called ruthenium, and we only had 5 years left. And it was in the previous 3 years, it had increased in cost by a 10 times factor, and it was going to get worse and worse and worse. So the industry looked at developing alternatives, and they found an alternative, and they were able to derive that alternative from aluminium waste, aluminium mining waste, which was almost an endless supply. So, you know, sometimes the swings and roundabouts, and sometimes those things change. But ultimately, you know, resource impacts, biodiversity impacts, and, you know, pollution, obviously.
Yep, makes sense. Okay, last question. So what's the difference between the EPD and LCA rate? Can you?
So LCA rate is a comparative study between a business as usual worst case product that's commonly available,
Yep,
and the product that we're studying. So it's a comparison between the two that we turn into numbers and then a rating.
mm-hmm.
An EPD is just a study of the impacts of the product that we're looking at. No comparisons. And in fact, under the standards, we're not allowed to make comparisons with other products in an EPD. So LCA rate is the only way you're going to be able to get a comparative analysis of products compared to a single base case. So that's the benefit of LCA rate. You can look at the entire flooring sector, excluding ceramic tiles. Any flooring, you can compare the eco points of the products to each other in a scientifically valid way, because they're all compared to the same base case. So that's unique. That's unique in the world, that opportunity with LCA rate.
Yeah, no, for sure. Look, you've certainly opened my eyes to the a Global Greentag product finder. I'll certainly be spending some hours on that one. So thank you, David. That was awesome. Plenty of information, information overload. We'll might have to have you back again in 2021.
Happy to.
Awesome. Well,
Thanks,
thank you. Pleasure. Thank you, everyone, for tuning in, and thanks for a huge 2020 for the climate movement. We are gaining momentum, whether COVID stops us or not. It won't happen, and we're set for a huge 2021. So I'll see you all back here February second Wednesday for the Builders Declare Roundtable. Thanks again, David. Cheers.
Thanks all.
Bye.